We are solving absolute value inequalities of the form the absolute value of u is less than c. So if we are saying that c is some positive number and this u represents an algebraic expression, something with an x, then what we are going to be saying is that the absolute value of u is less than c is the exact same as if u is between positive c and negative c. What in the world does that mean? Well, let me give you a concrete example here real quick. If you are looking at the absolute value of x is less than 3, what this means is that all of the numbers that are smaller than 3 are solutions to this inequality. Visually, this means, as I mentioned in the last section, this means all of the numbers that are the same distance away from 0 that are exactly between negative 3 and positive 3. All of those numbers, if I plug it in here in my x, will be a solution. 0, the absolute value of 0 is 0, which is smaller than 3. Even if I pick a negative 1, the absolute value of a negative 1 is a positive 1. This is exactly 1 away from 0, so it is also a solution to this. Now, if I look at it in another way, I can say that all of the numbers that are bigger than negative 3 and at the same time are going to be smaller than positive 3. This is a compound inequality, bigger than negative 3 and smaller than positive 3. So what we are going to be seeing here is that x has to be exactly between positive 3 and negative 3. In this case, because this was strictly less than, I'm putting parentheses around this graph. This right here is the graph of the solution. This is the graph, and the solution written as an interval would be all of the numbers between negative 3 and 5. All right, let's do an example. We want to solve the absolute value of x minus 2 is smaller than 5. So this is the same scenario as before. My absolute value expression is already alone. I do not need to do anything. And what that means is that whatever is inside right here, inside my absolute value expression, has to be exactly smaller than positive 5 and greater than negative 5. Think about the graph, the number line. It has to be to the right of negative 5 and to the left of positive 5. Now we are solving this inequality as a three-part inequality like we did in the section previously. We are adding 2 to everything, to all three parts. This is why this is called a three-part inequality. So we are getting negative 5 plus 2, that's a negative 3. This goes away. We have isolated the x inside the middle. And I see that my inequality now looks like this. All of the numbers that are greater than negative 3 but smaller than positive 7. And visually, this is exactly what I expected. If I say right there's negative 3 and this is positive 7, then now my numbers that are working in the sense of it turns this into a true statement when I plug a number in, are all of the numbers that are bigger than negative 3 and at the same time smaller than positive 7. And these are all of the numbers that are directly between negative 3 and 7. Now, because this was a strict less than inequality, I get parentheses. If I would have had less than or equal to, I would have turned it into brackets. All right, now if I write this down as a solution in interval notation, then it will look like this. Round parentheses, remember we had strict inequality. All of the numbers between negative 3 and 7. All right, let's do another one. Ooh, this one looks a little bit more complicated. There is more to be done because the left side, the absolute value expression, is not alone yet. Now, do not confuse this with solving algebraic equations. You cannot distribute the 3 just simply in. We have to isolate the the absolute value expression. This part right here. The absolute value of 5x minus 2 has to be alone. Now I can do this by first adding 20 to both sides. That will then give me 3 times the absolute value of 5x minus 2 is less than or equal to 39. Now I'm going to be dividing by 3. Remember, this is 3 times this absolute value, so inverse operation of multiplication is division. And I will get the absolute value of 5x minus 2 has to be smaller than or equal to, let's see, 39 divided by 3. Don't use a calculator for stuff like this. That will be positive 13. And now I am at the same place where I was with the last example. And that means now I can do the same thing. This inside expression right here, the 5x minus 2, all what I'm doing, I'm writing this down. It has to be greater than or equal to a negative 13, smaller than or equal to the positive 13. Think again about a number line. It has to be between negative 13 and positive 13. So this inequality right here I'm solving by isolating my x in the middle. So the first thing to be done is I'm adding 2 to everything. What are we going to get? Negative 13 plus 2, that is a negative 11, is greater than or equal to 5x, which is negative 11 is smaller than or equal to 5x, which is smaller than or equal to 13 plus 2, that is 15. And now I am dividing everything by 5, and I will get negative 11 over 5 has to be smaller than or equal to x, which has to be smaller than or equal to, well, 15 over 5, that is just 3. So, in words, my solution has to be between negative 11 fifth and 3. As a graph now, do we have enough space here? As a graph now, if I would graph this, this will look like this. Let's just say negative 11 divided by 5 is here. Somewhere over here there is positive 3. So all of the numbers that are bigger than negative 11 over 5 or smaller than positive 3, but also the numbers themselves. Why? Because we had less than or equal to. So I am writing my solution, as always, in interval notation, and I will get, remember, brackets in this case, from negative 11 over 5 all the way up to positive 3. Okay. So, the next inequality. Well, there is only one left. Solving absolute value inequalities of the form, the absolute value of u is greater than c. So, if I'm trying to solve something like this, then if c is some positive number again, and u represents an algebraic expression, we have seen this before, then the absolute value of u is greater than c is equivalent, meaning it's the same as u is smaller than the negative c or u is greater than the positive of c. Let's see how I can visualize something like this. Well, I am drawing a number line, and I will try to look at the absolute value of some number x is greater than positive 3. Remember, the last one was smaller than positive 3. So I have 0 here. Let's say positive 3 is here, negative 3 is there. What does this mean if I think about in terms of distance? All of the numbers that are more than 3 units away from 0 are these numbers here. They are to the right of positive 3 and to the left of negative 3. So in other words, there is a gap in between. And my typical solution set for inequalities like this, if I write it in terms of intervals, I have to collect two intervals. The one on the left here that goes from negative infinity to negative 3 in this case. From negative infinity to negative 3. Infinities always get parentheses. Negative 3 gets a parentheses because this was strictly greater than. And then over here I had the interval from 3 to positive infinity. And how do I combine these two? With a union sign. All right, let's do an example. We want to solve the absolute value of x minus 2 is greater than or equal to positive 5. So we do not have to work for the isolation of the absolute value bar because it is already alone. And that means now I can immediately turn this into two separate inequalities. Remember, to the left of negative 5 and to the right of positive 5 means x minus 2 has to be to the left of negative 5. That means smaller than negative 5 or equal to negative 5. Or to the right of positive 5 means greater than or equal to positive 5. Maybe this helps. This is to the left of positive 5. This is to the right of positive 5. If you think about it in terms of on the number line. So these inequalities now we are going to be solving. What are we going to do? Well, we're adding 2 to both sides in both cases. Now I need to erase this here. I am adding 2, and I will get x is less than or equal to negative 5 plus 3 plus 2 is a negative 3. Or I'm adding 2. No, the 2, let the 2 stay here and let this go away. I'm adding 2 to both sides, and I will get x has to be greater than or equal to positive 7. So this means, as a graph, if I am putting this on a number line, I have a negative 3 here, I have a positive 7 right there, and this one means that was, remember, to the left, that is smaller than a negative 3, and because it is included the equation, I have brackets. This one, remember, this was to the right, and that means greater than or equal to positive 7 is to the right of positive 7. And I'm writing this down as an interval, and that means, let's have a look, the interval from negative infinity all the way up to negative 3, this was the left branch, forms the union with numbers that are bigger than positive 7. This was the right side.